This question, a crane is used to remove an object from bottom of the lake, as you can see in the image. The object is a cylinder of height h and a depth of a lake is d, as shown in a figure. You can see the depth d is there and height h. The cylinder is removed vertically through the water at a slow and a steady speed. So we are moving it at a constant speed. The cylinder comes to right at a position where it completely above the surface of a water as shown. The diagram is not to scale. So this is not to scale the diagram. The graph shows how the tension in the cable varies with the distance as the cylinder is lifted from a bottom of the lake to its position in figure 2. So this is at the bottom of the lake and this one is position to figure 2. The graph shows how state the expression for a distance P and Q. So what will be the expression for a distance P and for distance Q? So distance P is basically like if we say this is P. So what is basically P? The tension in the cable, as I mentioned, we apply like we keep it constant. So this distance, how it is given by if this total distance is the first figure, and this is once it is removed out from it. So P is given by a formula that is D minus H. So D is the total depth minus the H. So D is the total depth minus the H, will get P. And then expression for Q. What is the expression for Q? So Q is basically it is completely removed. How much distance has moved? So that is equals to D only. Like when it is completely removed, how much distance it has moved? That is the total distance will be equal to D. And what about when we are taking it out? Look, when we are taking it out, as I mentioned, it is at a steady speed. So when it is at a steady speed, the resultant force should be constant. So here, this whole is P. And when it is completely out, so that is equals to D. So what is P equal to if we want to find P? So P is D minus H, like the total depth minus the height, we'll know how much distance is moved. And what about D? D is the total distance moved when we completely take it out, because this is a point where it is completely out. And this is a point where it is near the surface. So that's why one is D minus H, another one is D. So if we have to explain the graph, what happened basically in this graph, as I mentioned, the cylinder is moved vertically through a water at a slow and a steady speed, at a constant speed. So when we are taking it out, weight is acting downward and the tension in a spring is acting upward. Because, and what about the frictional force, the force or a viscous drag or a drag force? That will be downward. But they mention that it is moving at a steady and a very constant speed is there, but also they specify slow. So when speed is slow, the viscous drag or a drag force is negligible. So we can neglect this. So expression, when we are moving it up, it will be T equal W plus F, means the weight plus the viscous drag or the drag force. And here, there is another force. There will be an upward force from the fluid, and the upward force from the fluid is known as upthrust. So when we lift it or when we try to lift, there will be an upward force from the fluid and that is known as a upthrust. So U will be there. So upthrust will be added to this side. So we can say upthrust, which is acting up, plus tension is equals to weight plus viscous drag. But in the question, as it is moving very slow, so the drag force or viscous drag is negligible, or we can say approximately zero. So we can say upthrust plus tension is equals to weight, or tension is equals to weight plus upthrust. So there is a constant weight plus upthrust is equals to tension. So there is upthrust is constant. If the upthrust is constant, weight is also constant. So that's why there's a constant tension in the string, as you can see, till point P, until it reaches the surface. So when it reaches the surface till this point, when it reaches till this point, what is the expression? The expression is tension is equals to weight minus, not plus, this will be minus. So tension is equals to weight minus upthrust. But then what happened? When it is come out from it, like the moment it will completely come out from, or when it is coming out from the fluid, so the upthrust, what happened to the upthrust? Because upthrust is a force of a fluid. So upthrust start to decrease. As the upthrust start to decrease, when it is completely out from the fluid, that moment upthrust is zero. So if upthrust is zero, the tension will be equal to weight. So first the tension was weight minus upthrust, but now the tension is equals to weight. That's why the value of a tension will increase. That's why you can see the value of a tension is higher here, but initially it was a smaller value. Why it was smaller? Because upthrust was also contributing to the upward force. That's why the tension was smaller. But once it is out from the fluid, the upthrust is zero. As a result, upthrust is zero. That moment, the tension will be equal, tension in the cable will be equal to weight. And this object, when it is completely out from the fluid, the moment it is completely out, so the tension equals to the weight, or we can say compared to the initial when it was inside, the tension will increase.